car has to travel a distance s on a straight road. The car has a maximum acceleration A and a maximum deceleration B. It starts and ends at rest. Show that. Sorry, I did part 1 the other day, so don't worry about that. Doesn't affect part 2 anyway. Show that if there is no speed limit, the time is given by this. Now, what I did was I tried my usual trick. Remember the trick we discussed earlier? That if I knew all the answers, so if, for example, if the acceleration was 3 and the deceleration was 5, what could I say about these two times here? 5t and 3t. Is that all right? So if the acceleration is A and the deceleration is B, what could I say then? AT and BT. All right? Now, believe it or not, I'm leading us down a rabbit hole and it won't work. Okay, but you have to know why it doesn't work in order to spot it in an exam and to choose another route. Okay, so this is BT, this is AT. What do we call the max here? What do we call this? V usually, don't we? Okay. The problem is it gives me a specific answer, doesn't it? So would you agree that's total time? And what is total time by our logic? AT plus BT has to equal this here. Is that okay? So if we get AT and BT on its own and it equals that, we're like, hooray, we got it right. No big deal, everything's cool in the world, okay? So our usual trick is we usually use tan X and tan Y, don't we? It's one of our many tricks. So what do we write down here? Tan X equals, come on guys, V over, and that in turn equals A. So V would equal ABT. Go with that. What about tan Y? V over AT, and that equals, and therefore V equals. That's what I was saying earlier. Sometimes you just get the same information twice. Nothing to be gained there, right? I see S is in the answer. What can we say S equals? Would S equal the area of the left triangle plus the area of the right triangle? We good? So let's try that out. So what's S equal to? A half BT times what? V, yeah. And plus next part, a half AT times V. Okay, no bother. So S equals, phi BT over 2 plus V8, oh yeah, same deal. Now here's what I did yesterday, right? I decided to just factorize out the V, all right? And what did I get left with there? BT plus AT equals S. I cross multiplied the 2 to get 2S, cross multiplied the V down, and look, I got my BT plus my AT. Only problem is it doesn't match the answer they gave me. So I'm like, oh. And guess what? I didn't make a mistake either. I'm looking at this approved question because I wouldn't know if I'm right or wrong, would I? All right. All right. Now, what we're going to do is we're going to go back to a different idea. And the different idea, once again, when I'm explaining to myself whether an idea works or not, what I do is I make up a scenario where I know all the answers, okay? So here's what I'm going to do. I'm going to make the acceleration more aggressive than the deceleration, and I'm going to make up all the numbers so I know them, right? So this is what I would have done in the video. I'm going to make up a phi value of 24. I'm going to pick an acceleration and a deceleration that divides into them, any two factors I want. I'll use 4 and 6 for example. In the previous video I used 3 and 8. I'm just trying to teach you that it doesn't matter what way you're setting up, okay? Sorry. Acceleration has to be 4, deceleration has to be 6, only because I drew it that way. Deceleration is more aggressive than the acceleration. Now, what I would usually do is, we tried this trick already where that's 6t and that's 4t. And that didn't really work for us, did it? Didn't work for us, right? So we're going to think of this another way. Now, what we could say here is that, how long does it take you to get to 24 seconds if you start from rest? What's 24 divided by 4? This is 6 seconds, okay? And this is 4 seconds, okay? Only for this question, all right? Now, what we're trying to say is that as a fraction of total time, t, how do you find out how much time you spent accelerating as a fraction of total time? So total time is 6 plus 4, would you agree with that? Which is the ratio of your acceleration to deceleration is 6 is to 4. And your time spent accelerating would be 6. Would you agree with that? If I was to sort that out for the letters again, what would it look like? D over D plus A. So your time spent accelerating is D over D plus A. Can anybody predict what would be your time spent decelerating? What? Oh, sorry, multiply by total time. Would you agree with that? Has to be multiplied by total time, because this would be 3/5 of total time compared to 2/5 of total time. 3/5 of 10 is 6 seconds. 2/5 of 10 is 4 seconds. So we have to just, it has to be multiplied by total time, okay? Now, what about this one here, the shorter one? It's 4 over 6 plus 4. It's 2/5 of the total time. Would you agree with that? That's acceleration over deceleration plus acceleration times time. Everybody cool with that? What do you think I'm going to do with this formula here? So I'm going to get rid of everything else. Okay, none of this matters. And what we're going to look at, instead we're going to use A and B, aren't we? So get rid of all this nonsense. Get rid of this nonsense here, it didn't work for me. So what I'm going to say is that this is now total time t, all right? We know that acceleration is A and deceleration is B. So what can we say here then? This one is the deceleration divided by B plus A. That's the fraction of the total time it takes, and multiply that by t. That this time is this part here. Everybody cool with that? Can anybody make a prediction on what the other one's going to be? What? Yeah, A over B plus A times t. Now, I need to get capital T on its own, and capital T has to equal all this. Is that right? Total time taken has to equal all that chunk on the right. Now, in order to make this happen, what we're going to do next is we need an S in the answer, don't we? What's the only way you're going to introduce an S? You can call this T1 and this T2 if you want. What's the only way you're going to introduce an S into your answer? a half VT1 plus a half VT2. Everybody okay with that? What can I change T1 and T2 for? Yeah, I can do. A half V into B over B plus A times capital T. Is that all right? And the other one? A half phi times A over B plus A capital T. Who doesn't belong? V. Target V. Now, what did we say earlier about V? So, let's get it really carefully. Acceleration equals tan x, and tan x equals phi over T1. Is that all right? Tan x therefore equals phi therefore equals AT1. Is that all right? Is everybody happy with phi being equal to AT1? Okay. Now, if phi equals AT1, this is going to be fun. Which you mean is totally not going to be fun. All right, let's do this. It's going to be ugly. Do you know what we might do? I might just go back one step, if that's okay. So just trust me on this for a second. I'm just going to get rid of that last step we did. And I'm just going to throw in the phi substitution first and the T1 substitution second. That might make things a bit easier, okay? So what can I change phi to? So it's going to be A T1 squared. Is that okay with you guys? And this is going to be a half. Now, T1 squared, and this is going to be a half A T1 by T2. Is that okay with you guys? What can I factorize outside? Get rid of the halves. The hell with it. Bring the 2 out the other side, and what do we get? 2s. Bring this A underneath, and what do we get? 2s over A. And what's left over? T1 squared and T1, T2. Okay, let's keep going. It's getting ugly, but we're hoping it settles down to something nice. All right. What's B over B plus A squared? This whole yellow thing has to be squared to get this. So what do we get? B. Yeah, all right, great. B squared over B plus A squared and T squared. Are we relieved to see the T squared? Is that a relief when you look at your answer? Why is it a relief? You got the square root at the end. So that should send a message to you that what you're doing is correct. You're on your way. It's going to work out. Okay? Now, what's T1 multiplied by T2, which is going to be the yellow blob multiplied by the blue blob? AB over B plus A squared. So it's going to be AB over B plus A squared, yeah? T squared again. Now, we're so close and we're going to get it out, which is happy days. Factorize the top. What can I factorize out the top? T squared can come out. What else can come out? B, and what's left over? B plus A all over B plus A squared. Very close to being done, lads. Happy days. Cancels with that one. B plus A on the left is division of B plus A on the right is multiplication of B plus A on the left. Multiplication of B on the right is division of B on the left. And finally, what you do? Square both sides.